Hello friends, in this video lecture we are going to learn about the grouped and ungrouped data and accelerated live testing, okay, as a part of reliability engineering. Okay, so why we need grouped and ungrouped data? So already we have learned about the failure data analysis of the components, okay, in a very first part of the videos. Then once you gather that data, failure data we gathered, then that data is not in a proper format. Okay, that is very raw. Then we have to then arrange that data in a proper way or in a particular way. Okay, so there are different methods and there are strategic methods to group those data. Okay, that's why group data and ungrouped data, this particular concept is very important in reliability engineering. Okay, so what is ungrouped data and what is group data? When the data has not been placed in any categories and no aggregation, summarization has taken place on the data, then it is known as ungrouped data. So we have gathered huge amount of data, okay, from some tests, right, or failure analysis. Then we have put that data as it is in the computer, then that is an ungrouped data. But then for carrying out certain analysis on the data, we have to put that data in a proper format, in a proper way. Okay, then that is called as a grouped data. So grouped data is what? When the raw data has have been grouped in a different classes, then it is said to be the grouped data. Now this is very important to concise the data, okay, to get the abstract of the data, right? Because when the data in the raw form, you are not able to draw any inference out of the data. But to draw the inference, obviously we have to put that data in a particular proper format. Okay. So for example, you can see if you gather a certain information about the height of students. So let us say that these are the this is the data we have gathered as the height of students in centimeters. So we can see here 171, 161, 155 and so on. So we have this data. So if you see this particular data, so what you do, you skip this particular bottom part of this slide, and don't see this particular part. You see only this upper part. Then what conclusion you will get from this data? No conclusion, because this data is very raw form and you are not able to deduce any conclusion out of this data, right? So therefore we need to group this data in a proper way, so that then this data will become useful for the reliability engineer. Okay, so how to do that then? There are different methods. So this is one of the methods. Will form the intervals of the numerical values. So let us then arrange these ranges in this particular way. So from 131 to 140, like that. So to do this, first of all we have to identify which which number is the minimum number or least number out of this particular data. So we found that 131 is the least number that is found in this data, and maximum number is 190. Okay, this is maximum number 190, and we found 131 as the least number. Okay, so therefore then what will you do? Then we'll form the groups of the ranges. Okay, this is also called as a range. So we'll form the range. Okay, so we may form this range of interval 10, maybe 20. It's up to you. Okay, as per the requirement. So here we have taken as 10, 131 to 140, 141 to 150, that way. Okay, up to the maximum height, right? Okay, then we'll measure with count the number of the values in this particular raw data which will fall in that particular range. So we found that between 130 to 140 we got one reading only. Between 141 to 150 we got 7 readings. Okay, then between 151 to 160 we got 5 readings. Okay, this way then we count the all the uh, we count all the numbers in the ranges. Okay, and there are 41 actual readings we have taken, so this total must be equal to 41, so we got that here 41. It means that we have recorded all the numbers here. So now if you see this particular data, can you deduce some conclusions? Yes, we can definitely. How? We can see one conclusion should come in your mind that the students having the height less than 140 is very less, negligible we may say, but the maximum students have the heights between 161 to 190. This is one of the conclusions then that we can draw from this data. So it means that when you put the data in a particular format, then we can start deducing the conclusions. And these conclusions are very, very important. Okay, as useful information about a particular system. Okay, so then what is the class midpoint? Midpoint means what? Or class midpoint means what? It is the midpoint of the range 155. This is the 150, right? The midpoint of this 141 to 150 is 145. Okay, then what we'll do, then multiply number of students to class midpoint, then you will get these numbers. Okay, so therefore then we can easily find out the mean. So mean is nothing but the product of the number of students into class midpoint upon f, that is total number of students. Okay, so then we got 166.70 as your mean. So when you found this mean, it means that the mean height of that class comes as 166.70. So this value is really very important. This is the mean height of the student. So if you want to carry out certain measures for exercises, for medical health checkups, and suppose your doctor asks about what is the mean height of the students, then we may easily say that it is around 166 or 167. Then accordingly, obviously, the doctor will carry out some certain procedures, standard procedures. That's why this data is really very, very important. Some important points or terms that we must know about the data analysis. First is mode. So what is a mode? It is nothing but a number which is repeating more times in the data. It means that the data always try to tends to a particular number, that is nothing but a mode. For example, if you have this data, you can see here this 15, this occurring number of times. So it means that the mode of this particular sequence or this data is 15. Mode is 15. Then the median is nothing but the middle number of the entire data. Okay, let us assume that this is your data, right? This is your data. Then we have to arrange this data either in ascending order or descending order, and then observe the middle number. Okay, if the middle number is the say odd number, then there is no problem. But if the middle number is the even number, then we have to actually add 1 to that. Okay, so this is not that difficult, but just to understand this, let us assume this particular series we have arranged in ascending order. Then the median is nothing but n plus 1 upon 2. What is n? Is n is the middle number. That is nothing but your like 17. So 17 plus 1 is 18, divided by 2 is 9. So therefore we got this median as 9. Another important term here is your mean. So mean is very simple term. Mean is nothing but the average of all the terms that we have gathered in the grouped data or ungrouped data. Okay. Now another important point that we have to understand in the reliability engineering is accelerated live testing. So why we need that accelerated live testing? So try to understand why we need this. So at the very start, when you have started learning this reliability engineering, what we have learned is the failure data analysis. So how we get the failure data? We have to fail the components in a particular um, standard procedures. We have to fill the components. Now suppose the life of component that we have to test for failure analysis, if the life is much more, then what will you do? For example, the furnaces, then for example like your say the big machines like CNC machine. So you know the reliability is much more. So if you want to fill those machines, then you have to wait for a large amount of time. So do we have that time? No, because we want to check those components for failure data analysis. So it means that we have to fill those components. It means that when you want to carry out failure data analysis for such a component which have the large amount of life, we have to put the accelerated burdens over the components. Means what? We have to accelerate its life. Okay, by some or other way. Okay, how to do that then? You know, suppose we have a particular wire and we want to check its strength. What will you do? We'll apply the force. Suppose if we apply say 1 kg force and if it is deflecting through 0.1 mm and it is not failing, then what to do? We apply more amount of force. Okay, so we'll apply the amount of force, we'll add the force till it will get fell. In the same way, we have to do in accelerated life testing also. So what we do in this particular system, we put more stresses over the components, okay, so that the components will fail. Okay, but now we have to apply those stresses in a controlled way. We must know how much amount of stresses we are applying over the components. What is the effect of that? So that we can easily find out the life of the component. Okay, so that is called as accelerated life testing. Now there are two types of accelerated tests, quantitative and qualitative. In quantitative, what we do? We actually opt for the values. That is, for example, MTTR, mean time to repair, or mean time to failure, or mean time between failures. Okay, MTTF or MTBF or MTTR, like that. If you are able to, if you want to find out that, then that becomes your quantitative. Qualitative means what? Actually, we are going to find out the ways by which the components are being failed. Okay, so there are different types of quantitative and qualitative. So let us start with the qualitative. There are four types of qualitative accelerated life testing. Elephant test, torture test, HALT means what? High accelerated life testing, shake and bake tests. So what happens in these particular different tests? If suppose a compound is there which is carrying a particular load, say 1 kg load, and in application, and we want to find out its life. Okay, but what we'll do then? We are going to apply huge amount of forces on that component so that its life will be accelerated, but those forces will be controlled forces so that we can find out the life of that component. Okay, so that is called as elephant test. We are going to apply huge amount of forces, huge forces. Okay, then that is called as your elephant test. Torture test, this will happen in the same way. We are going to apply the stresses, okay, more and more stresses to the component so that its life will be accelerated and we are able to find out in minimum span the life of that component. So I will give you a very simple example. You must have tried in the theory of machines lab. That is nothing but to find out the fatigue life of a particular component. What do we do to find out fatigue life? We apply the forces and we apply the fluctuating forces to the component so that it will fail and we are going to predict its life. Okay, then HALT means what? Heavy or high accelerated life testing. What we do, we'll first of all find out the way the component is decaying. Okay, the component which is decaying. Then we are going to create the environment so that its decaying rate will be increased to a very high rate, so that then we can easily find out its life. Okay, for example, if the condition the atmosphere is says say comfortable to the component, and say expected life is 1 hour, also 1 year. If you put the double stress, the life will be 5 months or 6 months, sorry. And if you put triple force, then life will be 4 months, like that. So therefore, if you apply the 12 time forces, then what will happen? The component will is going to be failed in the 1 month. So that is the benefit of such kind of tests. So what we'll do to analyze the life of such components, we are going to apply or we are going to produce very severe conditions to that component, severe conditions, so that it will fail early and we are able to find out its, or we are able to analyze its life. Okay, then shake and bake tests. So this will happen when the components are moving at a very high speeds. Then in that, what we'll do in the same way what we are doing in the your fatigue life testing, in the same way we are going to do in the shake and bake tests. Okay, so these are about the qualitative accelerated life testing. In quantitative, also already we discussed, we are interested in MTTF, MTBF, that is mean time to failure, mean time between failures. So there are different ways to find out that we actually carry out in the quantitative test. Okay, so this is all for um, the 2 points that we have discussed in this particular video lecture. First is your grouped and ungrouped data, and second is accelerated live testing. So thank you for hearing this video lecture. Thank you so much.